equals 1 over x, and the interval is 1 comma 3. Perfect. Unbelievable. Maybe if I move it further to the right, it will stay in place. I don't know. Okay, so number 1, remember the graph. Always remember the graph. Between 1 and 3, no problems. Continuous and differentiable. So f continuous on 1 comma 3. Number 2, f differentiable on at least 1 comma 3. There's no third hypothesis. Then by MVT, there exists a C in the open interval 1 comma 3 such that f prime of C will be f of 3 minus f of 1 over 3 minus 1. And we have to find C. So I have to find f of 1, I have to find f of 3, and I have to find f prime of x. Can anyone give us f of 1?
1.
Excellent. F of 3?
1/3.
Very good. And f prime of x? Remember we talked about this? Please always remember this. I need this for chapter 5. So please remember this. Whenever we differentiate 1 over x, we get negative 1 over x squared. Good, that's all I need. This left-hand side in this equation is negative 1 over c squared. The right-hand side in this equation is 1/3 minus 1 over 3 minus 1, which is 2. From this moment on, it's just algebra. Okay, so I'll flip. Or maybe you should simplify first so I don't confuse you. Let me simplify first. So the left-hand side is negative 1 over c squared. 1/3 minus 1 is negative 2/3 over 2. It's 2 over 1. So negative 1 over c squared is negative 2/3 times 1 over 2. So now what is left? Both are negative, so I'm going to change them into positive. C squared must equal 3. The numerators are 1. So the only possibility here, c squared equals 3. I take the square root. Remember, c equals plus or minus the square root of 3. Are they both in 1 comma 3? No. Only c equals the square root of 3 is in 1 comma 3. The other one is negative 1.73, and it's in the negative part. So only this is guaranteed by MVT. Do we feel a little bit better about MVT? Do you think now we can move on to Newton's method? Yes?
Yes. Yep.
Very good. So this is 4.8. And you can say you're skipping again. Yes. That's the last section we have to go back to. Okay? 4.9 is with chapter 5. Newton's method. Okay. So follow me with my explanation, and then we'll state Newton's method. We're going to do it anyway through the example. So let's suppose I want to solve as an example. I want to solve the equation x cosine x minus 25 x squared equals 5. No one can solve this by hand. There is no algebraic method for this. So I will never be able to solve it. But Newton's method will help me do that. Okay, so what is the idea? So let's suppose the function is this. What function? Whatever equals 0. I can move 5 to the other side and create a function, and we're going to do that all the time. So I have a function, and this is my function f of x, and I want to solve this equation. I want to determine this. That's all it means. So finding the 0 or finding the x-intercept, they all mean the same thing. The 0 of the function, the x-intercept of the function, or the solution of this equation, they all mean the same thing, is this. I'm going to denote this by root, lowercase r. It doesn't matter. You can denote it the way you like. We're going to denote it by r for now. And of course, our best friend, let's say I'm using the intermediate value theorem, and I found an interval a comma b, 1 unit interval, where I know the solution exists. Of course, it's a continuous function. And if you remember from chapter 2, continuous functions, a continuous function that changes sign on an interval, it has to cross the x-axis, either coming from negative to positive or coming from positive to negative. If it's continuous and it changes sign, it has to cross the x-axis. Of course, at least once. Okay, so here's what Newton said. Using the intermediate value theorem for continuous functions, I found a 1 unit interval, let's say between 2 and 3. Of course, I'm zooming in because I have to explain, or between 1 and 2, or between 10 and 11, but 1 unit. It could be smaller, but not bigger than 1 unit. So let's say I have 1 and 2. I show that the function is continuous and changes sign. There must be a solution there. And let's say I want to start somewhere. There are some restrictions. So I'm going to put in parentheses and I'll come back. 2 restrictions though. But I want to show the method and then I'll explain the restrictions. Start somewhere. I call that the initial value. X naught or x sub 0, or the initial value that I choose. And of course, there are 2 restrictions. I cannot choose anything I want because I have to be careful, right? I'll explain in a minute. So let's say my x, which is either a or b. I can start with a or I can start with b. So let's say my choice is a. If I have 1, 2, let's say I start with 1. What does this mean? I'm telling you that a is a gross estimate of r. You can say, oh, okay. Far away, but okay, you're closer. Fine, then this number or this number. Okay. Then Newton said, okay, create this point, a vertical line, of course. So the function value for a and a, right? So this is the point of a comma f of a. Fine. At this point, he said, draw the tangent. Okay. Then he said extend it till it crosses the x-axis. Okay, fine. I will denote this by x1, comma 0. That's the point. It's on the x-axis, so y is 0. So this is x1. And I'm going to say this to you, and you tell me whether you agree or not. X sub 1, also called first iteration, I claim that x sub 1 is a better estimate of r than the original value I started with, the initial value I started with. Would you agree from my graph? Should I repeat?
Yeah, can you repeat the question?
Yes. So here's my question. I realized that in this 1 unit interval, the function that is continuous changes sign from negative to positive. So there must be a root, a solution, an x-intercept somewhere between a and b. I decided to start my initial value here. And I say to you, a for me is an estimate, not a good one, but an estimate of r. Then I drew a vertical line, it crossed the function. I created this point, obviously a, f of a. I drew the tangent line to this point. I extended it, it crossed the x-axis, and now I'm saying x1, so maybe I should write here much better as x0 f of x0, so I'm not confusing you. So my x0 is a. So now I claim that x1 is a better estimate of r than a was an estimate of r. Would you agree?
Yes.
Yes, because look, the distance between these two, so I'm getting closer. So this must be a better estimate of r than this one was. Agreed so far?
Yes.
Okay, let's determine x1. So I started with x0. I'm happy with x0, but I got a better estimate. I want to find it. Gee, how do I find it? So let's see. I have the slope of this line in two different ways. We just did that. So the slope of the tangent. Can anyone again tell me what is the slope of the tangent? No algebra, calculus now. What is the slope of this tangent?
F prime of a.
Yes, or f prime of x0. Awesome. A being x0. Awesome. Good. Now, can you tell me the slope of this line using algebra? Same thing, the slope of the tangent line using algebra. And of course, this point and this point. In any direction you want. y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. What do you think about these two expressions? I'll come back to my graph. I'm not finished. What do you think about these two expressions? Like this and this.
They're also the same.
They have to be the same. Awesome. So the f prime of x0 must equal f of x0 over x0 minus x1, or x naught minus x1. Remember what I'm after. So I started with x0. which was not good. But I have now x1, which is much better because it's closer. Okay, so I want to solve for x1. I'm going to swap these two or cross multiply, it doesn't matter. F prime of x0 multiplied by x0 minus x1 equals f of x0. I will divide by this. Okay, remember I'm solving for this. I move x0, just algebra, this is only algebra, there is nothing here. So negative x1 equals negative x0 plus f of x0 over f prime of x0, and I multiply by negative 1. I'm happy because I determined a better estimate of R. Not the best, but a better estimate. I got closer. Now it's time for me to give those two restrictions. See what happens? I have to be careful that the x0 or x0 that I choose does not make f prime of x0 0. Because I will never determine this. If this piece is 0, this doesn't exist. So that's my first restriction. I have to be very careful. I cannot just simply, hey, let's choose 1500. No. I have to make sure that f prime of this number I start with is not 0. That's the first restriction, very important one. Is that clear so far?